Hi all, welcome back to my channel. So far we have covered what are operators in Java, arithmetic operators in Java, relational operators, logical operators, unary operators, and assignment operators. So if you have not watched this video, I have given link in the description box. So from there you can watch this video. And now we are going to move with another operator video. So without wasting time, let's get started. So what is bitwise operator? Bitwise operator perform operations on binary bits, means zeros and ones. So we have different bitwise operators. We have AND bitwise operator, we have OR bitwise operator, we have XOR bitwise operator, we have bitwise complement, we have left shift, and we have right shift. So let's understand one by one. So first one is AND bitwise operator. So the meaning is it sets its bit to 1 if both bits are 1. So how does it works? When we have one bit and 1, so the answer is 1, otherwise 0. For example, we have 5 and 3. So system.out.println, we are doing 5 and bit operator 3. So first what we are going to do, we are going to convert the numbers into binary bits. So the number 5 is converted into binary bits. So binary bits for 5 is 101. For 3 binary bits is 011. So don't worry friends, this binary bits how to convert we are going to see when we are doing practical example. So now for now just understand the concept. So when we apply AND operator for 5 and 3, now what happens when we apply AND operator, it checks 1 and 1 is 1, rest all are 0. So 1 0 is 0, 0 1 is 0, 1 and 1 is 1, the rest all are 0. So I hope you understand, and the result becomes 1. So how this result become 1, this also we are going to see in practical video. So next is bitwise OR operator. So how does it work? In binary numbers, if any of the number is 1, for example 1 or 1, so 1 is present any of the number, right? So it will give us 1. So next is 1 or 0, 1 is present for the first place side, so 1. So 1 is not present in any of the place, so it is 0. It's as simple as it is. So 5 or 3 is calculated as per the binary expression is. So 5 is converted into binary number as 101, 3 is converted into binary number 011. So if 1 is present in both, then 1, rest all are 0. So 1 0, 1 is present, so 1, 0 1, 1 is present, 1. So 1 1, 1 is present, 1. So result is 7. Now next is bitwise XOR operator. How does it works? When the binary numbers are same, it is 0, otherwise 1. So you can see here 0 XOR 0, both are same, so 0. 1 XOR 1, both are same, so 0. 1 XOR 0, it is not same, so result is 1. So when we do 5 XOR 3, first 5 is converted to binary number 101, 3 is converted to binary number 011. So when both are same, like here 1 1, it will be 0, otherwise 1. So finally 1 1 0, and the result is 6. Next is bitwise complement. So it's very simple. If it is bitwise complement of 0, it will become opposite. So 0 will become 1, 1 will become 0. So a bitwise complement of 5 will be, when we convert bitwise into binary, it is 1 0 0 1 0 1. So opposite of it will be 1 0 1 0. So according to that, it will calculate result as -6. So in left shift we are shifting the bits on the left. For right shift we are shifting the bits on the right. So this is all about theoretical part. Let's deep dive into practical parts so that you can understand it better. So now let's move into practical part of video. We have covered bitwise operator AND, bitwise operator OR, bitwise operator XOR, bitwise complement operator. Then we have completed left shift. We have seen right shift operator. So let's understand one by one these examples. So first let's understand bitwise AND operator. So here I have written system.out.println 5 bitwise operator AND 3. So if you run this, we are getting output as 1. So how we are getting this output as 1? Let's understand. So we have number 5 and we have number 3. Guys, forward me, my drawing is not so much clear, but focus on concept. So 5 we need to convert into bitwise binary operator, and 3 also we need to convert it into binary. So for converting into binary we need to use a 2 raised to power factor thing. So 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 2, 2 raised to 3, and so on. So 2 raised to 0, what it will give value? 2 raised to 0 power means 1. 2 raised to power 1 means 2. 2 raised to power 2 will give us, it will give us 4. So 2 raised to power 3, it will give us 8. So 5 falls under this only, because if we see now, let's just place these numbers. So from descending order to ascending order we need to place. So 1, 2, 4 and 8. So these are the numbers. So which numbers we can consider so that we will get the addition as 5? So here 4 and number 1 is matching. If we add these numbers we will get output as 5. So for that fields we need to consider as 1. So here it will be 1, here it will be 1. So rest all will be 0, 0 and 0. So the binary value for 5 is 0, 1, 0 and 1. So rest all, like if we consider 8-bit value, then it's 4 digit only, right? So rest 4 digits will be 0, 0, 0, 0. So first 4 digits will be 0, 0, 0, 0, and then it will be 0, 1, 0, 1. Now for 3, how it will be? Which values we can consider so that total will be 3? Let me just put again values: 8, 4, 2, 1. Which two numbers we can consider so that output will be 3? So 2 and 1, right? 2 plus 1 is 3. So these two will be 1, 1, it will be 0 and 0. So till here you have understand, right? So let me just try to write this. It is 0, 0, 1, 1. Now let's perform bitwise AND operator here. The output will be, so how bitwise AND operator work? If both the values are 1, output is 1, rest all are 0. So both the values are not 1, so rest are 0. Second is 1 and 0, it will be 0. Third is 0 and 1, it will be 0. Now next fourth is 1 and 1. If both the values are 1, output will be 1. So finally we have got this number, right? So if we write this number in descending order, let me just write here. Space is not there. So 0, 0, 0, 1. So now if we write this number in descending order, it is 1, it is 2, it is 4, and it is 8. So finally which number is having 1 here, right? So output will be 1. So let me show you on slide. See, from this slide the output is 1. So friends, I hope you understand. If you still did not understand, I can explain it again. Just let me know in comment section. Now let's move to another bitwise operator, that is OR operator, bitwise OR. So 5 or 3. So what will be the output? Any guess? Let's run and see the output. So the output is 7. So how it will be? Let's understand. We have number 5 and we have number 3. So we need to take power of 2, right? 4 digits. 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, and so on. But since our digits are small, we can consider till here, right? You can go and you can take as much as you can. So 2 raised to 0 is 1, 2 raised to 1 is 2, 2 raised to 2 is 4, 2 raised to 3 is 8. Now we need to put these numbers in descending order. So the descending order is 1, 2, 4, 8. I have already told if there are many numbers we can put it here also. So 8, 16, 32 and so on. So but these numbers are very small, so it will be inside this number only. So now which numbers we will add so that we will get 5, 4 and 5, right? So this number 2. So for these fields we need to consider as 1 and rest will be 0. 0 and 0. So the finally binary number for 5 it will be 0, 1, 0, 1. Binary number for 3 it will be what it will be, which numbers we can add so that we can get 3, 2 and 1, right? So for this field it will be 1, 1, 0 and 0. So finally for 3 binary number will be 0, 0, 1, 1. Let's calculate binary OR operator. So 0, 1, 0, 1, 0, 0, 1, 1. So we are going to calculate binary OR operator, right? So for binary OR operator, how is the calculation? If there is any 1 in the decimal places, then it is 1, rest all are 0. So 0 and 0, 1 is not present, so it will be 0. 1 is present, it will be 1. 1 is present, it will be 1. 1 is present, it will be 1. So the final output for this number is 0, 1, 1, 1. Now let's just plate this in descending order. So 1, 2, we already have this number, right? 1, 2, 4 and 8. And what is our output? 0, 1, 1 and 1. So finally the output will be what? It will be 4, 5, 6, 7. So output will be 7. We are adding these numbers. Whoever 1 is present, that numbers we are going to add. So 4 plus 2 is 6, 6 plus 1 is 7. So answer is 7. Let me just show you. So friends, see, for that bitwise OR operator, the output is 7. I hope you understand this concept. So friends, for the bitwise XOR operator, bitwise complement and right shift operator, this you can do from on your own, because the video is become very much lengthy. But if you still want to have this tutorial, I can make it another tutorial, but if I want that much response from your side. So let's understand now the left shift operator. So if we do 5 left shift operator 1, what does this means? We need to do left shift operator 1 decimal for this number. So let's understand this. So let's first see the output. The output is 10. How? Let's understand this concept. Bitwise left operator. So the example was 5 left shift operator 1. Means we need to do 1 decimal left shift operator for 5 value, right? So one digit we need to shift. So first we need to convert this 5 into binary number. So how we need to convert, we already know, right? We need to take 2 raised to power 0 and so on. So 2 raised to 0, 2 raised to 1, 2 raised to 3, 2 raised to 4. Since our number is small, we are taking this much fractions only. So 2 raised to 0 is 1, 2 raised to 1 is 2, 2 raised to 3 is 8. So 2 is missing, sorry. Let's take it 2 here. So 2 raised to power 2 is 4. So let's put this number into from descending to ascending. So it will be 1, 2, 4, 8. So it will be so yeah, so which two numbers we will add so that we can get output as 5, 4 and 1. So for this the value will be 1 0 1 0, and rest all number will be 0 0 0. We are considering here 8 digits, so 0 0 0 0. Why we are considering here? Because we are doing left shift operator, so one digit will be shifting here, so that's why we are doing this. So one number we are going to shift, so this one will shift here, 0 will shift here, and so on. So how it will be? Here it will be 0, here it will be 1 is shifted here, so this 0 will shift here, this 1 will shift here, so 1, so this 0 will shift here, so rest all it will be 0 only, no impact, right? 0 0. Now finally what we will get? We will get 1 0 1 0 after left shift operator, right? So for this we need to write from descending to ascending. So here it will be 1, here it will be 2, here it will be 4, here it will be 8. So now which numbers are 1? That we need to do addition. So number 1 is having at 8 and 1 is having at 2, so 8 plus 2 it is 10. So the output for this is 10. Let me show you. Shift operator 5, left shift operator 1, the output result is 10. So friends, I hope you understand this bitwise operators in Java. I have not covered OR XOR. I have not covered Bitwise XOR, Bitwise Complement and right shift operator because video length is becoming very lengthy and I need to explain you the concept very much clearly. So for this we have completed Bitwise operators in Java video. So friends, what next? We are going to say next video on ternary operators in Java. So friends, if you are new to my channel, I am creating Java tutorial videos from beginner level and that too from scratch. So if you don't want to miss any update for my upcoming videos, don't forget to subscribe my channel. Also like, share, comment on the content if this video bring out any benefit to you. Happy learning with Java and see you in the next video.